Hi guys, welcome to the notes for H3-2. Today we're going to look at monomials and how to apply more properties of exponents. The top three exponent rules you see on this slide are ones that we talked about yesterday. Today we're going to add in a couple more. You'll see down in the bottom left corner, if I am dividing two numbers with the same base, all I'm going to do with those exponents is subtract the top one minus the bottom one. The other new property that you'll see is when we have a fraction, okay? Now notice our bases can be different here, it doesn't matter. Okay, so when we have just some sort of fraction and I raise it to a power, I'm going to raise the numerator to the power and the denominator to the same power. So the whole thing gets raised to the same power. All right, let's move on. First one says simplify. We have 9xy to the third over 15x squared y squared. When we see a monomial like this, that means there's no addition or subtraction happening. We just have a product in the top and a product in the bottom. We can take this and break this apart into compatible parts here. For instance, I have 9x to the first, y to the third. I can take that and let's just kind of break this apart. So I'm going to take my numeral from the numerator and my numeral from the denominator. I have 9/15 times x over an x squared times a y to the third over y squared. Notice there's no addition or subtraction, so it allows me to do this. If I multiply this all back together, it gives me this. If I multiply all this back together, it gives me that. Okay, so I'm just separating it apart here so that I can look to reduce. Now 9/15 breaks into 3 times 3 over a 3 times 5. Right, if I want to reduce this, I'm looking for what factor goes into both of them. And we see there that 3 does, so I can cancel out a pair of 3's, and I have just a 3/5 left over. And when I do an x over an x squared, it's like an x times an x, I can either apply the rule where I'm going to subtract the exponents, or I can look at it as, right, this factor is going to cancel out with that factor. And remember, this is a 1. These are 1s when things cancel out. So I have a 1 over an x left. And then if we look at this one on the end with our y to the third over y squared, well, y to the third is the same thing as y squared times y over a y squared, in which case we have the y squareds can cancel, and it's going to leave us with just a y in the numerator, and we'll put it over 1 in our denominator, and then we can just multiply it back together, right? 3 times 1 times y is 3y, and our denominator, 5 times x times 1 is 5x, and that is our simplified answer. Okay, is that the only way to do it? No, it's not. Okay, there's about, countless ways that you could approach these problems. You just need to make sure you know how to do one of them and that you do it correctly. Let's look at number 2. I have the fraction 5x over 4y squared, and then we're multiplying it times a 2y over x squared, and that's being raised to the third power. So order of operations states that we're going to have to deal with that exponent first, right? We need to take care of this first. So that's like 2y over x squared times itself 3 times, or we could use some of those exponent rules. So we could say this is like saying a 2y to the third power over an x squared to the third power, in which case, right, that's the same thing as saying 2 to the third times y to the third over an x squared to the third. And when we take that and we try to simplify that down, right, 2 to the third is going to be 8. So that's like an 8y to the third over x to the sixth. Okay, so let's just go ahead and let's just rewrite this now down as 8y to the third over x to the sixth. I'm going to bring down the other side here. We've got 5x over 4y squared. Now you have options here. You could either simplify, then multiply, or you could multiply, then simplify. If I look at this and I want to multiply everything together, I could do a 5 times an 8, which gives me 40. And then I have x, y to the third. On the bottom, I could do a 4 times a 1 is 4. And then x to the sixth y squared. But after I multiply them together, now I have to look to reduce it again. Now it kind of looks like this problem from over here, number 1. Right? I know that I have 40 over 4 times x over x to the 6 times y to the third over y squared. Well, 40 divided by 4 is 10. That's in the numerator. When I cancel out one of my x's, right, I'm going to have 1 over x to the 5th. And I'm going to cancel out my 2 y's here with 2 of these ones. So that's going to leave me with just a y in the top and a 1 in the bottom. So we end up with our answer being 10 times y over x to the 5th power. Okay, so if you didn't want to multiply it, if you wanted to try to simplify first, look at what you can do here. It's already factored, right? So we could look at this as, okay, well, 4 goes into 4 once, and 4 goes into 8 twice. So we could reduce this and call this 1 and call this 2, right? I have an x right here, right? This is like an x to the 1st, and this was an x to the 6th. I could take that and reduce that to x to the 5th. And I could take my y squared, cancel it out, and cancel out 2 of my y's here to give me just a single y. And then when we take it here and we look at it, right, we have a 5 times a 2y, and then we have a 1 times an x to the 5th, and that's going to give us the same thing, 10y over x to the 5th. Just notice it's a little bit more messy here and a little bit more complicated to keep track of everything, but it can be faster if you're able to do that. If you don't want to do that, then take your time and do the method that got us the answer over here on the right side. Either way, it's the same answer. Looking at number 3, I have negative 4x to the 5th times y to the negative 2nd. So just remember on this, right, I can't have a y to the negative 2nd. So when I think about it, this is negative 4 over 1 times x to the 5th over 1 times a y to the negative 2nd over 1. Well, we already talked about moving this down to the bottom, so really it's like negative 4 over 1 times x to the 5th over 1 times 1 over y squared. When you put it all back together, our negative 4 and our x to the 5th never moved. There was no reason to move them, but our y squared ends up being on the bottom. Do you have to show all of this work, or could I have just taken this and moved it to the bottom? Yeah, as long as you understand what you're doing. So we all have to make it to that point. So maybe you need to practice a little bit to make sure you understand that. And then, yeah, by all means, if you have it down, you can use the shortcuts there. Number 4, we have x to the 11th times y to the 10th over an x to the negative 3rd, y to the negative 1st. So I have x to the 11th over an x to the negative 3rd, and I'm going to just multiply it by a y to the 10th over y to the negative 1st. Okay, I put my compatible parts together. Now, I have a negative exponent down here and a negative exponent down here. My exponents up here are positive, so those aren't going anywhere. X to the 11th is going to remain on the top, right? And then if I need to move all of this, right, it's going to move up here. So I have x to the 11th times an x to the 3rd. And then I have times my y to the 10th, and I'm going to move this up times a y to the 1st. And now we can just go back to our very basic properties, right? This is multiplication. So x to the 11th times x to the 3rd is going to be x to the 11 plus 3, which is 14th. Y to the 10th times y to the 1st would be y to the 11th. And our answer is x to the 14th, y to the 11th. The 5th one, same thing. Maybe you want to take it, break it apart first, see what you get. I'm going to do that. I have 5/20ths times x to the negative 3rd over x squared times y to the negative 9th over y to the negative 2nd. The 5/20ths is pretty easy to reduce that, right? This is like saying 4 times 5, so we'll cancel out our 5s and we have 1/4 left over. I have an x to the negative 3rd and an x to the 2nd. Well, this one's got to move. This one's got to stay, right? So if we move our x to the negative 3rd down to the bottom, it becomes positive. So we have 1 over x squared times x to the third. And here, you'll see that we've got a y to the negative ninth and a y to the negative second. So we're going to move this up to the top. We're going to move this down to the bottom. And what we're looking at right now is y squared over y to the ninth. Now they're both positive, okay? But we can take it and still cancel them out, right? Y squared over y to the ninth is the same thing as saying y squared over y to the seventh times y squared. We can cancel out the y squareds. So we're looking at right now our middle term, x squared times x to the third, would be x to the fifth. And we still have our 1/4 out in front. If we try to take it and put it all back together, we've got our 1 times our 1 times our 1 is 1. On the bottom, we have 4 times x to the fifth times y to the seventh. It would be 4x to the fifth, y to the seventh. And that is our answer. Is there other ways to do it? Yes. Okay, so if you have a question about another way to do it, or whether or not you're doing it correctly, please ask your teacher. Number 6, we have -2 times x squared times y to the negative fourth, and then it's being raised to the negative second power. Okay, there's a couple ways that this one can be done. Is one way correct more than another way? No. So as long as we're applying our properties and we're applying them correctly, we can go about this in different ways. For a problem like this, where we have a grouping symbol, right, and it's being raised to a negative power, the way I like to think about it is let's just go ahead and do it like this: -2 x squared y to the negative fourth, okay? And then I'm going to take this and break this apart. I'm going to keep the positive 2 here, and then I'm going to just kind of break it apart and make it a -1 afterward. I'm going to worry about the 2 first, right? I'm going to worry about squaring everything first. And then I know that this -1 is just going to make everything flip afterward. So we can do that at the end. So let's just focus right now on this part of it. We've got the -2 x squared y to the negative fourth to the second power. And then we'll come back and worry about that -1 in just a second. So I've got a -2 to the second power times an x squared to the second power times a y to the negative fourth to the second power. I know that that's a negative exponent, and we'll deal with it in a second, okay? But let's just do this part of it first. -2 times -2 is 4. X squared to the second power is x to the fourth. And then y to the negative fourth to the second power is going to be y to the negative eighth power. Okay, so right now we still have all of that, okay? And it's still being raised to that negative first power. But before we deal with that negative first power, let's go ahead here and deal with this -8 first, right? If it's y to the negative eighth, that means it's going to move to the bottom. We'll have 4x to the fourth, and now it's going to be over y to the positive eighth power. So that inside is now pretty simplified, and it's being raised to the negative first power. Now, if we took this and we raised everything to the negative first power, if we applied those properties and we raised everything to the negative first power, it would just be like saying 4 to the negative first times x to the negative fourth times, divided by our y to the negative eighth. We just have to take everything and flip it over, right? We'd have, move our y to the top, make the exponent positive. Our 4 would move to the bottom, become a positive exponent, and then we'd have an x to the fourth down there. Okay, that is the correct answer, y to the eighth over 4x to the fourth. But rather than just taking it and applying that to all of them here, right, just know this. If I'm applying this entire fraction to this exponent, or this exponent to this fraction, to the negative first power, that just means that everything in here is going to have a negative exponent. So we're just going to end up flipping this fraction. If I flip this fraction, I get y to the eighth over 4x to the fourth, right? And that's all to the positive first power now. And since we took the reciprocal of it, right, we don't have to do anything else because this is the same thing as that. So it can be a little tricky. You just have to decide which way you want to do it. Looking at number 7, this would be a good opportunity for you to think about that. Okay, so we have a negative 2 times a to the third times b to the negative fifth times c to the power 0 over 3a squared b to the third c to the seventh, and the whole thing is being raised to the negative second power. All right, so it's your call which way you want to do it. Since I have this fraction inside, maybe we just deal with all of this first. Let's not even look at this negative second power just yet. Let's try to clean up what's inside first to make it a little bit easier. Right, I have a negative 2 over 3. When I have a to the third over that a squared, right, we'll know how to simplify that. We'll have that b to the negative fifth over b to the third. We know how to simplify that. And we have c to the power 0 over c to the seventh. We can simplify that. Let's just go ahead and do that real quick. So in my numerator, I'm going to have a negative 2 over that 3. We know that this a squared is going to cancel out with this, leaving us with just an a. This b to the negative fifth is going to move to the bottom with our b to the third, giving us a b to the eighth down here, and just a 1 on the top. And c to the 0 power is going to be 1, and that c to the seventh isn't moving anywhere. So what we've actually looked to do is simplify this and make it a little bit easier for us as we move forward, right? We have negative 2 over 3, a over 1, 1 over b to the eighth, and then we have 1 over c to the seventh. Put it all together, it's just negative 2a over 3 b to the eighth, c to the seventh. Now it's still being raised to the negative second power. So you can do it like we just talked about in that previous problem. Let's think about it as negative 2a over 3b to the eighth, c to the seventh. Right, let's raise this to the positive second power, and then we can come back and deal with the negative first power in just a moment. So when I take my negative 2 and I raise it to the second power, I know that's going to give me 4. I take my a and I raise it to the second power, I know I have a squared. When I take my 3 and I raise it to the second power, I know I'm going to get 9. When I take b to the eighth power and I raise it to the second, I know that's b to the 16th power, right? We're multiplying when we raise a power to a power. And then we'll have a c to the 14th down here. Now we've squared it all, and since it's just being left to that negative first power, we'll just flip it. Right, so we're going to have 9 b to the 16th, c to the 14th, over 4a squared. And that is our answer. Let's move on. Number 8. We have s to the power of k plus 2 divided by s to the power of k. Well, we can apply our property here where if we're dividing two numbers with the same base, we can subtract their exponents. This is the same thing as s to the power of k plus 2 minus our k at the bottom. And now we'll just simplify and get s to the power of 2. Right, k minus k gives us 0, so we're just left with s squared. Number 9, a to the power of 2m times b to the power of 2m plus 1 over a squared b squared raised to the power of m. With this one, since we have this quantity down here and it's being raised to this power, let's go ahead and apply that first. Remember, we're going to be multiplying our exponents, right? A squared to the power of m times b squared to the power of m will give us a to the power of 2m times b to the power of 2m. Remember, this is our denominator. Our numerator is still the same, so I'm going to just go ahead and bring it down here. We have a to the power of 2m times b to the power of 2m plus 1. It looks like we have compatible parts here, right? We've got a to the power of 2m over a to the power of 2m. Well, what does that give you when you divide something by itself? Right? That's going to give us just 1. That part's going to simplify to 1. And then what are we going to get over here? We have b to the power of 2m plus 1 divided by b to the power of 2m. Well, that would be like saying b to the power of 2m plus 1, top minus the bottom, minus the 2m. And that's going to give us b to the power of 1. So that whole expression just simplifies to b. And that's it. Last problem, same kind of thing. We've got t to the power of n plus 1 times t to the power of n minus 1 over t to the power of n. The order of operations would state, let's simplify this group before we get to the whole entire thing. So t to the power of n plus 1, since we're multiplying times the same base, we'll add the other exponent. And right now that's over t to the power of n. This is going to give us t to the power of 2n in our numerator. And we're still over t to the power of n in our denominator. And now that we are dividing away the same base, this will be the same thing as saying t to the power of 2n minus n, which is going to give us t to the power of n. And that's it. If you have questions about any of these problems, please make sure you reach out. Otherwise, thanks for watching.